Okay, listen up everyone. If you would, do 721. If you're not doing 721, then carry on with what you're doing. Okay, everyone, 100% submitted their reports, which is good. So I downloaded those today. Why haven't I marked them yet? Because some people get extenuating circumstances and there's no point in marking one lot and then marking another lot. I will mark them tomorrow. Got 8 hours booked in for all to do all that. So with a bit of luck, by close of play tomorrow night, the information will be there. Whether you'll get it, I doubt it, because the office have to release it first, but rest assured it will be marked and we can proceed with the second assignment. Okay, what I've seen so far looks good. It's because you've been in the labs, that's the key thing to all of this. Actually, it's not hard, you've just got to be here. And what happens is certain students don't turn up and they think they can just write a report. Well, it's just not going to happen, I'm afraid. And, so keep the faith and stay in the lab and work for the 3 hours that you have here. Okay, so the deadline was last Thursday for assignment 1. All done, it's all water under the bridge. We're on to assignment 2 now. Now the deadline for that, 21st of the 3rd. What's the date today? 7? 7th today? Okay.
No, 6.
6. Okay, so you've got 2 weeks and a day to work on this. That may not seem very much, but don't forget you're now experts in this. So you know how to use multi-sim, you know how to run a simulation, you've got some idea about how to make things as well. So it shouldn't be too difficult, and you can almost use your previous report as a bit of a template as well, can't you? Because it's not going to be wildly different, the layout of it, and you know, you're going to have a circuit diagram in the same place and all that kind of stuff, yeah? So now has come the time to select the one thing that you want to build. Now if you look round on the board there, I've projected the page up there, I can just about see it from here. You need to choose something. It doesn't have to be one of those, but that's what today's session, or the first hour of this session, is about. Myself, the gentleman there, and Mike when he comes in, will come round, show us something that you found through reference. Of course there's going to be reference. You're not going to sit down there and design something from scratch, because that's not what this module is about. It's about using reference. So find yourself something on the web you like. What would you like to build? There's a few suggestions. Simple radio receiver or transmitter using transistors and discrete components. So you can just buy an IC that is everything. The pre-stage, the mixer, the amplifier, everything. But that's a bit boring, and you're not going to get very many marks for buying an IC and sticking it on a board, are you? So that's why when I mark something, if it's built out of discretes, I tend to be more impressed than I do if someone's just ordered an IC that does everything. That's not to say that's not what you would do in industry. In industry, you would take the path of least resistance. So if there is an IC that does what you want, you just buy and use it, right? But what we're talking about here is just sort of a bit of experience of doing things. So simple radio, they're a job, and you know from building the oscillator for your metal detector actually how difficult that is to get the oscillation in simulation. It's hard, right? That's what you're going to run to if you try to make a simple radio receiver. But it doesn't stop people trying. There's something somehow magical about a radio, because when it works, you know full well it's working as it should do. Another suggestion, digital capacitance meter. Yeah. Quite a sophisticated piece of equipment, but not that hard to find a circuit which will do that for you. So you put a capacitor across it, and it gives you a reading according to the size of the capacitor. A bar graph-based spectrum analyzer. We ran this as one of the assignments a few years ago, and what that can look like is a series of LEDs that light up according to the input signal. You can even get a bit carried away and make it look like an analogue meter that's got lots of LEDs that light up according to the volume and so on. It's quite a nice one because it's a pretty simple circuit that's repeated many, many times. So it's just a threshold comparator, the bar graph-based spectrum analyzer. DC to AC inverter. Anyone know what an inverter is? Someone turn something upside down, but that's not the answer I'm looking for here. Inverter? Anyone got a caravan, or parents got a caravan? Caravans, boats, that kind of thing. So what we want to do is we want to run things. We want to run a mains television, we want to run a mains liquidizer, blender, whatever. What we want to do it from 12 volts. That's what an inverter is, it enables us to do that. So we go from DC to AC and we can use it to run domestic appliances. Resonant power transfer system, if anyone wants to see it, because I have to be a little bit careful when I show this. Does anyone want to see my resonant power transfer system? So basically I've got a propeller on one end and a gap that you can put your hand in between, and I can transfer electricity over free space, so that's the claim. I'll go and get that in a little while. Resonant power transfer system, got a good research project on that at the moment for passive active tags. An amplifier, you can build an amplifier. How do you test the amplifier? Well, it's easy, you've all got mobile phones, you just stick the jack socket in there and you can test the operation of your amplifier. That's a popular one as well. Filter, to a lesser extent, but I can imagine a bank of filters with bass, treble and mid-range where you can adjust those. Energy harvesting, a bit abstract that one, but trying to harness small amounts of energy that might be around us or in front of a Wi-Fi transmitter or something. The one that 20–30% of people sometimes take are digital dice. I don't mind the digital dice, but I am getting a little bit bored of those, so I'll leave that choice to you. Hidden wire detector, that's a nice one, because the hidden wire detector is quite similar to the first project you did, but it's just looking for, well, more than just pieces of metal. So in other words, you just put it across the wall. If you're going to hang a picture up or something, you don't want to bang a nail straight through the electrical cable, do you? So that's a suggestion there. Or finally, a circuit of your choosing. Will I be slightly more impressed if you have chosen your own one, or I'll be slightly more impressed, and this is Mark's, if you've shown a bit of thought. That's all it really comes down to. So it could be one of those, but with a variant on it or whatever. But what I want you to do in this session, for only the first hour really, is I want you to have a look on the web, decide there's something that you'd like to own and show your children in the future and all the rest of that kind of stuff. Something that's going to be useful to you. Make that choice. When you've made that choice, or you've got 4 things and you can't make your mind up, stick your hand in the air, we'll come round and see you and we'll say, that's good for the following reasons, or maybe we wouldn't recommend that because we don't think you'll be able to do this section of it. Okay? You'll also get feedback given the time you've got. 3 sessions. This might be a little bit too complicated. Other feedback you might get, well, you've got 3 weeks and you've only got 2 components, so it may not be sophisticated enough. Okay, but draw on our advice first before you start making something that either you can't make or is so simple that you're just not going to require any good marks for it. Is that okay? So kind of consider that a sign-off. We'd like to see everyone, certainly before this session, but even before the break, I'd like to see everyone showing me something that they're then going to put into Multisim and go through the whole process again. So it's bill of materials, it's a description of the operation, it's a simulation. If you want to make it, then make it. I don't mind. If you make it, you'll get more marks, of course. Why wouldn't you? If you don't make it, will you fail? No, of course you won't. But, yeah, you get the idea, I think. Okay, any questions on what we're going to do for the next hour? Okay. Get that Google finger working and see if you can find something that you like. Okay. And we'll be hovering about.